have a theory into energy that
Energy?
fields meet and become composite particles of quarks and electrons.
Field mate?
Well, not meet. Fields bend in such a way as to become a formation of continued energy.
All right. What does that mean?
Basically, fields don't meet; they bend. The closer a field gets to another field, the more it bends.
Okay, what does that mean?
That means
Okay, let me
field.
actually can I ask the question a little more specifically?
Yeah.
So we know that electromagnetic radiation, electromagnetic waves, travels in perpendicular waves. One wave goes this way, and then the other wave travels perpendicular to it. That's why when you use a polarizing filter, it only filters out some of that information. And if you take polarized sunglasses and you look at a computer screen, a lot of computer screens are polarized. If your glasses are if uh, the polarization is made by doing these microscopic slits. If those are perpendicular to the polarization of the computer screen, then the computer screen will look black. But what's really funny is if you just turn your head 90 degrees, you'll see the screen all of a sudden. So we know that electromagnetic waves travel in these parallel line, or not. Why did I say parallel? In these perpendicular angles to each other, right? So what would it mean? So that I understand. What would it mean to bend them?
Well, they're traveling in that sort of line because they are being bent in such a way. Um, they're both attracted to each other each way, but they're being bent perpendicular to each other.
But that's not what I don't. That's not what it means to bend something. I don't think.
What would it mean to bend something? It'd be to change its vector in such a way as to bend it, basically.
Right. So I mean,
Um,
a piece of
when you
glass
see,
can do that. It's called wave refraction.
yeah, but when you see energy, energy bends in such a way while traveling. So energy is actually traveling much faster, but it's being bent in its travel.
I have no idea what that means.
The speed of light is well, the speed of energy is greater than the speed of light.
No,
But
that's not true.
yeah, our measurement of energy is energy while it's bending. So it's traveling
That
a greater
I have
distance.
I have no idea what that means, and that's also not true. The speed of light is the speed of causality. Energy cannot energy cannot affect something greater than the speed of light or
Yes,
whatever.
that's because it's being bent while traveling. If you if
But you said
you
it can,
if you
but it
travel in a
can't.
spiral, if you travel in a spiral, bending the whole way while traveling at light speed, your travel velocity is actually greater because you're traveling the distance of the spiral. But the point
Okay.
I was trying to make is there's composite particles of quarks and electrons and light. These composite particles join together to form wave motions and patterns of difference in different forms and numbers and facings.
And what are they?
But what are they? They're octahedrons in the shape of a diamond.
I really doubt it. How do you know that?
How do I know that? Because I've done 9 years of study into field mechanisms.
What?
I have my own theory, and I've done 9 years of study into it.
Okay, well, what experimental evidence do you have to verify it? Like, what's her name? Rosalind Franklin. Although nobody had seen the DNA molecule, she know that by doing X-ray crystallography or something like that, or it's X-ray diffraction, but you use crystals to do it. She knew how to do that in a very specific and sophisticated way, And so when she rendered images of the DNA molecule taken through these prisms, she was able to ascertain that the DNA molecule has a spiral shape to it. And then Watson and Crick took that information and some other information about bond energies and whatever else, and the Chargaff's rule, the proportions of elements and molecules and whatever in DNA, and figured out what it actually looks like, right? So I'm asking, how did you figure out that these things, and I already forgot what the hell they're called, are octahedral? And they're octahedrons and diamonds at the same time? That doesn't make any sense.
A three-dimensional diamond is an octahedron. It has 8 sides.
Sure. That what do you call that? It's it's like the Dungeons and Dragon dice.
No, it's not like the dice. A diamond, like a playing card diamond.
Yeah, I know. Is it just called a tetrahedron? Isn't it? Isn't it just called a tetrahedron?
No, a pitch called a tetrahedron.
Oh, so what do you call it when it's doubled? I feel so stupid. Okay, so whatever.
It's an octahedron.
This is okay. Okay, I'll take your word for it. So how do you know that that's what these things are?
From observation, from effects of quarks and gluons and light, from my own observations.
Okay, well, how did you gather that? How did you gather that data?
From a simulation of energy, which led to a Big Bang.
Are you trolling?
No, I'm not trolling. If you simulate energy at 148.9% of the speed of light, and you put enough energy in just one spot, it creates a Big Bang, and the energy expands and creates black entities and black holes. These black holes slowly create particles, which are these composite particles. And these composite particles come together to form atoms of hydrogen and helium. Stars are slowly born from that. Basically, the energy itself folds upon each other and jets out in 2 directions, causing a relay of a coning of the universe.
You got all of this from a computer simulation?
Yes, the computer simulation, if you were in it, would look exactly like this world.
All right. Well, I got an RTX 3060 graphics card. Do you think I could do this simulation?
Well, it'll depend on your processor also, but you could simulate smaller versions. It's on an XYZ plane.
Is this published somewhere?
It's copyrighted, but not published. It's being tested by certain individuals.
What's the copyright?
Basically, my theory put forward, copyrighted.
I didn't ask you what is a copyright. I asked you what is the copyright.
It's copyrighted on a few publishing sites that rejected it for not being scientific enough.
Yeah, that that sounds right.
Well, I don't come from a science background. I come from self-study and self-teaching, and I don't know the scientific terms to put. So my viewpoint is just fields and mechanisms of fields. Basically, the formation of these particles is like energy being bent while being attracted to a great enough pole. You'd have like poles coming into to an opposite pole, and they'd form four directions of intake, which would create 4 lines of force. 4 lines of force continue on to attract an opposite, and they'd bend again and continue on to the point of returning fields. So the returning field would vortex into the particle. There'd be like 2 pinpoints of concentrated force where at the top and the bottom of the diamond.
Okay. I got a,
Um,
I got a thing on my head.
the lines at the edge of the
I,
diamond would be
I didn't. Okay,
would
here
be
I have an
field.
idea. I have an idea. Oh shoot. Oh, where did they go? There's somebody. All right, never mind. Go ahead.
The lines at the edge of the diamond would be field spiraling as they're bent by each other and continue to travel past each other.
Naturally.
Yeah. Now, due to the vortex of returning field, when you release magnetism, you attract magnetism. You attract the opposite.
Yeah, I was
So
doing that
due
the
to the
other day.
vortex, when these particles connect with each other, they can connect in such ways as to either follow this vortex or be between the vortex and the release force. So they can have wave motions. They can be stable. They can they can join to the spiraled outcome of the edges and move back and forth along them. So if you join two of these particles together, these composites, you have a light particle or a neutrino. Now, a light particle is going to move along its edge back and forth and wave force.
Yeah. Well,
It's going to be a wave from
yeah,
this.
I knew that.
But the overall field mechanism of each light particle is different. There's different patterns of its motion, where there's going to be a greater degree of north or south force on blue or red light. But it won't be registered because it is a wave. To read it with a simple magnet is to keep it in the same travel line, because when it waves, it's going to resist the field or attract to the field. The closer it is when when resisting, the greater the force of it moving away. So how do I put it more understandable? Basically, it's going to travel straight either way.
Okay.
Now you see light effects of blue, red, and yellow. Where yellow is more of a just plain magnetic wave. Yellow likes to ground to gravity. Gravity itself.
Yellow light likes to ground to gravity.
Yeah, that's why we have a yellow sun.
That no, that is not why the sun. The sun isn't literally yellow. It's white.
The sun's white.
Yeah, it looks yellow because the light waves get bent by. That's just light traveling through the atmosphere. It bends.
Yeah, but it's specifically yellow light that gets bent towards the Earth.
Yeah. Well, it's actually a lot. The blue and the purple light does not bends the least. So we're actually getting all of the light. It's just that some of it is filtered out, and yellow just happens. We're getting the reds and the oranges too. It's just that the yellow is this term doesn't make a lot of sense because it's color, but the yellow is louder, so to speak, and so it's what we end up seeing most of.
Okay. Well, but according to me, gravity itself is magnetic wave function. If you magnetically wave all the components of an atom, and the electrons magnetically wave, your magnetic waves are going to tune in with the timing of other magnetic waves, and you're going to attract to other atoms based on the timing of that magnetic wave. Because all magnetism and all particles are going to avoid repulsion and move into attraction. The only reason for resistance between atoms, say like O2 and things like that, is the electron proximity can be greater in aspect outward, creating more of a south charge.
What does that mean?
What does that mean? That means there's a south charge to O2.
No. What does that mean?
That means the electrons are in a far enough orbit away from the proton to have greater effective distance proportional strength.
Therefore,
they're going to travel about avoiding each other.
Electrons? Well, all electrons avoid each other.
O2 is going to travel about avoiding each other. So
all gas molecules avoid each other.
Yeah, but all gas molecules have a similar aspect of charge to cause repulsion.
I have no idea what that means.
Cause them to repel, cause like pole resistance.
Like pole resistance?
Or not resistance, but like pole repulsion.
Which is what?
Which is two like charges doing the opposite of attracting.
Okay, sure, I get that. I mean, gases bounce off of each other. I mean, that's just the nature of gases.
Yes, the nature of gases has certain degrees of magnetic waves and certain degrees of positional outlet of force, where they're going to either circumvent each other if they're in the right position, or they're going to avoid each other. Gases like to do this,
circumvent like and avoid are circumvent and avoid are synonyms.
Okay, orbit each other.
Well, no, gases don't orbit each other.
Some gases form patterns of motion around each other.
They can. There's like, I don't think Brownian motion applies to gases, but the electrons in a, so if you have like a system with gas molecules moving around, the electrons get, like if two atoms get close to each other, the electrons of one will push the electrons of the other, more towards the other side of the atom, and that can cause like weird little very small attractions, these intermolecular forces between them, we call them. So this is why no gas really acts like an ideal gas, for example, but I'm not sure if it has anything to do with all of this stuff.
It has to do with the field attraction of either magnetic wave or charge. Everything has to do with the field attraction or repulsion of magnetic wave and charge.
Okay. Again, I don't know what that means. I know that opposites attract, or sorry, that opposites attract and like charges repel.
Yes, it's basically putting it like that. Everything is going to act accordingly to whether they're going to be opposite or like. And then other things are going to act in accordance to frequency and magnetic waves to attract.
I don't think that's a good description. So if you have sodium and chlorine atoms, if you make this sodium molten and you mix it with the chlorine atoms, it will chemically react. The chlorine atoms will steal an electron from the sodium atom, and it'll release a lot of light and heat energy as it does that, because it's reaching a lower energy state. That's why atoms form compounds. But that has nothing to do with the charge, because both of those atoms are neutral. It has to do with the electronegativity and the first ionization energies of those elements.
Well, the sodium and the chloride atoms are similar to friction in the regards of their electron interaction, creating heat.
Friction? What?
Well, in the similar aspect of heat being created.
Heat is just a type of electromagnetic radiation. When the electron is absorbed, when they have to release energy, and so that energy is released as electromagnetic radiation.
Heat is one of those composite particles and is magnetic in nature.
Heat is not a composite particle. it's carried by, you can say it's carried by photons, but photons are, I mean, they're particles in a weird sense, but they're massless particles.
Well, they're massless because they're traveling such a way as to be attracted to north. There's a certain,
what does that mean?
There's a certain field mechanism where the south expands more and the north
you need to tell me
doesn't
what
expand as much.
You got to tell me what the south is, because I have no clue.
Negative charge.
So you're telling me that photons are inclined to move towards positive charge?
Yes, all magnetics is inclined to move towards positive charge. This is due to
no, it's inclined to move from positive to negative.
No, negative's inclined to move towards positive.
Electromagnetic radiation, like the last time I checked this, which was very recently, I'm pretty sure that the electricity, like current itself, goes from positive to negative, which whatever. It goes from positive to negative, but what's called drift velocity, the direction that the electrons are moving, is actually opposite of that. But if this was true, then if I had an extremely strong magnet, I should be able to make photons move towards it. And I'm not aware of any research that backs that idea up.
No, you wouldn't be able to make photons move towards it because the photons themselves are going to wave. And every time they wave, they're going to be closer when they hit like poles. So they're going to go like pole and opposite pole, like pole and opposite pole in a wave. So if you have just one field, it's going to move toward then away. It's going to affect the wavelength, but it's not going to affect the motion, or not going to affect the direction.
But literally no idea what that means. So light is inclined to move towards a north pole.
If you use a wave, you can bend light. If you use a wave of magnetism at the same speed that the light is waving, if you use such a wave, it'll bend the light.
Has this been done?
This can be observed with light effects of, say, red and blue next to each other. If you take a red laser and a blue laser and you put them beside each other, they're going to bend.
That could be. That sounds like it's possible. I've never heard of it.
This can be observed with the double slit experiment, where you put light through it. It's waving. It's going to either attract or repel based on like poles and based on opposite poles.
Light doesn't have a charge.
Light has a magnetic wave, and the charge cannot be registered with just charge. You cannot measure the charge with just a magnet.
So then how are you claiming that the light is being moved or repelled by charge?
It's not being moved or repelled by charge. It's merely changing its wavelength due to charge.
Oh, I really disagree with that.
Well, with a double slit experiment, you're going to have like poles and opposite poles. Like poles are going to wave at times that are going to move the light away from the initial direction, and opposite poles are going to wave in such a way as to move the light towards the center.
Okay, what is the source? Where are those poles that are making the photons move located? Where do they come from?
They come from these composite particles that are going to basically.
You said that light is a composite particle.
No, it has composite particles.
No, it doesn't.
Then what basis do you give me to say that it doesn't have composite particles?
Well, if I were just to go on the internet and look up, does light have mass? The answer would be no. and there are no particles without mass. Quarks, neutrinos,
What about
muons,
gluons?
electrons,
Do gluons have mass?
these things all have mass.
The magnetic wave effect creates a seemingly masslessness. When you magnetically wave as a light particle, you're going to travel along energy in such a way as to magnetically wave in tune with it. So light particles travel at the speed of energy due to their magnetic waves.
They are magnetic waves.
Yes, but they're a particle also.
They behave like waves and particles, but they don't have mass.
Well, the the photons themselves interact with the electron, as the electron has a magnetic wave centrally.
Okay, so the photon is part of the standard model of particle physics, but it
So
doesn't have mass.
its mass cannot
Well,
be
it's a
measured
force
for it
carrier.
only. Yeah, but its mass cannot be measured as it only interacts with electrons.
Okay.
It has a magnetic wave, and the electron also has a magnetic wave, and its timing of magnetic wave gets it to join the electron and either be reflected or be released as a new light particle that is of the same color, or be split apart as heat, or be changed into a different colored light particle based on the electron that it's meeting.
Okay, I got a question. So the double slit experiment, we're saying photons go through, and their interaction with north or south poles or whatever you were saying is what causes them to get deflected and end up over here versus over there. What is the source of the charge that makes one of them move?
What is the source of the charge? Well, when you have a magnetic wave, you're going to push out both north and south charge.
Okay, so what is the source of the wave?
What is the source of the wave? It is the motion of these composite particles that are joined together.
You said that the photons don't have a charge, or that it can't be measured, and so it can't interact with or affect things. So that's why I'm asking this question, because you said something vaguely similar to that. But in this experiment, you are telling us that it's like the interactions between them that are making them move. But you said that the photon doesn't have a north or a south pole or anything like that. So this seems like it's self-contradictory.
No, what I said is the photon of red and blue are charged, but they magnetically wave, and they cannot be measured with another charge, but they can be measured with a magnetic wave. And light itself is a magnetic wave, which causes the double slit experiment results. So if you use a magnetic wave to measure them, you're going to get results of such. And light itself is a magnetic wave, so it's going to affect it in such a way.
Spaghetti.